exactly the same. You're going to factor them. You're going to do quadratic formula. The wrinkle is going to be they're going to have double angles in them, half angles in them, or require, this one type of problem is going to require some extra algebra, some fun, exciting algebra. So, not that much different. It's just that you've got to deal with, remember, some of those double angles have three choices. So how do I know which one to pick?
Can you scale to how hard this time it's going to be? 1 to 10? 7.
See, yeah, 7. That's probably good.
I can just tell. Like, all that going to happen is fast.
I'm concerned, those of you who didn't do your doubles and halves are going to have more trouble than those of you who did do them in the identity chapter. Okay, so what you need to look at when you read these, and this is what we have a tendency to buzz by, you've got to read the angles. You can't look at that and go, that's a sine minus a sine. It equals 0.
Sine 1, sine 2.
Oh, thank you. Good point. This is a radian problem. Okay. And so, yeah, you're going to go, whoa, that's a sine of angle x minus a sine of twice the angle. It's a double angle. You cannot solve when you have two different sets of angles in here. You got to have all the angles the same.
Take an angle out.
So you, what do you mean take it out?
Like we did on that last one.
Yeah, but this is not sine squared. This is the sine of angle 2x.
You just take an x out then?
Nope. Sine and x are inseparable.
Sine 2x equals 2 sine cos.
Yes. You got to look at it and go, oh, I have to use an identity on it. This is going to require your yellow sheet like no other. So you've got to go look up what's the identity for the sine of a double angle because it changes it back to a single angle.
So you're going to go 2 sine A cosine A.
Yeah. So in this case, 2 sine x cosine x. And then, now you got all the same angles. Now you can do the algebra on it.
Good. Just take a...
What? Now you can take a sine of x out. Because you have a common factor. And these were all multiplied back here, so I'm allowed to pull something out. So that will leave me 1 minus 2 cosine x, yes.
On these quests, are you giving this to us, or you're going to have to test the memo?
On the quest, I will, like last time, I won't give you the fundamentals, and I won't give you the special angle. I'll give you everything else.
So you'll give us the double angle.
I'll give you doubles and halves, yes. I don't ever expect you to memorize those.
There's confidence.
Would you be able to reduce that 1 minus 2 cosine x down more, or would you have to put that equal to...
Well, you may be thinking it kind of looks familiar, but it's not. It's kind of like some of the double angle identities, but it's not one of them, and it's not squared.
Yeah, because that one's just... That
So since it doesn't have the square on it, this is just a normal solve each one. You can solve each of these factors. Sine equals 0.
Yep, and the other one would be...
If I set the other one equal to 0.
Negative 1 half, wouldn't it?
Yes.
No positive one. Could you subtract the 1
Yeah, it would be
over?
positive.
Or I'm gonna move the cosine over, make it positive, so I would have cosine equals, yeah, 1/2. Okay, and you're going, yes, we're in radians. When I'm working a problem in radians, I have to come out with special angle values. So 0 and 1/2, those are good numbers. So okay, where's sine equals 0?
0.
At 0, and anytime it equals 0, there will be 2 places. Because if it can equal 0 on the right-hand side of the axis, it can equal 0 on the left-hand side of the axis.
Does it have to be positive?
What do you mean positive? Okay, 0 doesn't have positive or negative, so it doesn't matter. That's why it could be on both ends. Because there isn't negative 0. Yes, x equals 0 and pi. And then, okay, cosine equaling 1/2 means it's going to be in the quadrant. It's pi over 3, but what quadrant? Okay. So 1 and 4 is where cosine's positive. Pi over 3 is our reference angle. So the first quadrant angle is no big deal. The first quadrant angle is pi over 3. Okay, now, how do I get the fourth quadrant angle? Yeah, because I'm going all the way around. So if this is 2 pi, I'm 1/3 short, and if I make that into a common denominator, 6/3 stack up 1/3 is 5/3. And I didn't have any fractions up there, excluded values, anything to make me have to go check my answer, so we're good. So the point is, if you have different angles in the problem, you have to go use your identities to change them into all of the same type of angle. You can't have a mixture of angles and be able to solve it. Yeah, you can. Yeah, if it uses any of the fundamentals, all those identities, you're free to use them anytime. So, and actually, we're going to see that here in a second. What now?
We will use 10, so they can see the same.
You can, okay, well, A, you're not going to solve a problem where you think about a tangent undefined, so you don't have to worry about tangent being undefined on that one. All right. This is what I call the ultimate problem of trig equations. If you remember last year's ultimate problems.
No.
The easy one?
The easy ones?
Yeah. Sorry, I like the square.
Okay, but the big square root ones, which in algebra 2, though, that was the first time you ever did a problem that was about 10 steps long.
That's awful.
Now you all don't think so much of that. But back then, that was a big deal. This is probably the trickiest of the trig equation ones because the algebra here is going to be pretty intense. But I like this one a lot. It's a good challenge. And this is in degrees. So, you look at it and you go, well, okay, I got a sine of x, a cosine of x. My angles are all the same. This should be no big deal. It should just be like the last assignment.
Yeah, no problem.
Okay, but the problem is, how are you going to solve when you have two totally different trig functions?
You're gonna verify, aren't you?
Well, it's not verify, but I'm going to have to eventually.
Would you divide the two?
I could divide the two, but that'll make me have, well, 1/2. That'll make me have fractions. I don't want fractions.
Two sides going in the other side, I'll say 0.
I could move it to the other side, but will it help? Don't write this down, because if I move sine over, can I combine it with anything if I move it over there?
Yes.
Yeah, it doesn't go anywhere or do anything. In fact, somehow I need to get sine changed into cosine or cosine changed into sine.
Are we going to use some difference identities on this?
Oh.
Not likely to use some difference. Okay, so what's the one and only identity that changes sine into cosine?
Number 6.
Good old number 6. But to use our good friend number 6, what has to be?
Get them on the 1. Get them on the same side. Turn them into 1.
They have to be squared before I can use that identity. These are not squared.
But we can square everything.
I can. Remember, it's legal to square whole sides. You can't square individual terms, you can square whole sides. So you want to keep them on opposite sides.
So then 2 sine.
So, yeah, I'm going to square this whole thing, but the trick is going to be I'm going to square the whole right-hand side.
So 4 sine x squared.
Yes.
And then you're gonna have to FOIL that one.
And I'm going to have to FOIL that one. Yeah. But thank you for realizing, yes, I have to FOIL that one. Okay, so first are going to be 1. Outsides and insides are going to be the same.
Would it be minus 4 cosine x?
Because it's going to be a negative 2 cosine x twice.
Yeah.
So it's actually going to be negative 4 cosine x plus, I got to square the last one. 2 cosine times 2 cosine will be 4 cosine squared. Okay, well, I mean, it looks at the moment like I made a bigger mess. But the point is, I wanted to get it all in the same trig function. Can I now use identity number 6?
Yes, because you could cross out, because you could take the negative 4
Okay.
plus that.
So do I want to change the sine squared or do I want to change the cosine squared? There's only one sine squared. There's several terms with cosine, so change the sine squared. So if I change the sine squared, according to identity number 6 over here, what does sine squared equal? It is 1 minus cosine squared. So that's what's going in this position. And we're eventually, at least we now have an entire problem all in cosine. So we can finally clean it up and do something with it. But let me point out the downside of this one. Does anybody remember the ultimate problems with the square roots when we squared both sides? What you had to do at the end of the problem because you squared both sides?
Check. You have to check.
You have to check your answers because sometimes your answers don't work. Squaring both sides can create answers that actually aren't true. So when we get done, we will have to check all our answers, and we will check them by calculator.
You're doing it wrong.
Cross them out.
You have to distribute.
Some of them will work, some of them won't.
So you say it does not work.
Yeah. Okay, do I have to distribute the 4?
Yeah.
Yes, exactly. That's what we should do next.
Well, 4 minus 4
Cosine squared.
So you can cross off that
Cross off 4.
No, you can't.
No, you're right, you can't.
If you think, oh, I could ditch the 4 cosine squared. No.
Wait, well, can you, nah, you
So
couldn't.
it's wrong. You factor it.
But if I get it, it's quadratic. It's x squared. Get it all on one side, set it equal to 0.
Can you add the 4th cosine x, oh, never mind, it's not squared.
So
Yeah. So I need to just get it all on one side. I would move it to the right so my squared terms are positive. So I'm going to add a 4 cosine squared,
8 cosine
squared.
and I'm going to subtract a 4.
So,
Negative 8 cosine squared minus 4 cosine minus 3.
Yes. Minus 4 cosine minus 3.
okay, so then
Now put it in the formula.
now can you take cosine out? No,
No,
you have to factor it. You have to factor it.
Okay, and now here's the trick. We hope we factor it.
Just stick it in the quadratic formula.
You have to do
Well, I mean, there's chances here. It's not going to be the world's easiest factoring.
Stick it in the quadratic.
Okay, what do you think? 8 and 1 or 4 and 2?
4 and 2.
And then I know it's got to be 3 and 1. Well, yeah. If I put the 3 out on the back end, that's going to make 12. 12 and 2. That's not doing it. So if I put the 3 on the inside, does 6 and 4 make a 4?
No, it's the quadratic formula.
You could try 8 and 1.
8 and 1, the 4 and 2 definitely don't work. 8 and 1, well, I definitely don't want the 3 out there because I surely don't want 24 cosine. It won't get it, sorry. So, okay, factoring doesn't work. Yes, it's the formula.
Why are you excited about this? Do you get to like from saying?
Yes, I do. It's why you teach. Torture students.
I hope you know this is going on the record.
I know.
Over all of YouTube.
Just realize you're talking.
I can make this one private. Okay, so yeah, it's the quadratic formula. You've never died from the quadratic formula.
You don't really problem with that.
Yeah.
Okay, so negative b is going to give me positive 4 plus or minus the square root of.
Ooh.
Okay, b squared is going to be, I'm just going to square it at 16.
Just make that a negative.
Over 2 times 8. Okay, so yeah.
Relatively good numbers.
The good thing is, we see we've got 2 negatives in there. This is going to be a plus, so that's going to at least not be imaginary or something. So we're going to have 4 plus or minus square root of something. 32 times 3 would be 96. 112 over 16. Okay, so then, do I need to pull up a calculator and actually punch this in to show you what to do? We did this last class, you should know.
There's no numbers run with the 112.
Okay.
A plus or minus, you cannot cross off the 4 and 16.
Yeah. If you can't cancel the 4 into the 16, you have to be able to cancel out of all 3 if you're going to cancel with a plus or minus in there. You might break down square root of 112 and then you might get to cancel. It's not worth your time and trouble. We have to throw this in our calculators anyhow to get the answer, to get the angles. So just throw it in your calculator. Don't waste your time.
You want to do where?
So if you punch that in there with the plus, I believe you will get a decimal value of something like 0.911. That's rounded off. You could type the whole original in if you want to. Okay. So now what you all would need to do though, you punch that in there, you get the 0.911. Leave that up on your calculator screen.
Is that the degree?
Nah. Cosine equals that. So we have to find the angle where cosine equals 0.911. So how do you tell your calculator to give you the angle? You have to do inverse cosine on your calculator of that. And I would copy it down from above. I would carry the whole decimal down. You'd have to do inverse cosine of that. We are in degrees on this one.
12.3.
And you should get,
12.
you'll get 24.3, which that's your reference angle. That may or may not be an answer. Okay. And I would go ahead and finish this whole problem before I go do the minus version. Because I would go, okay, right now I know that I had a positive 0.911, so therefore this answer is in first and fourth, and 24.3 is my reference angle. Yep. This is, I told you, this is the nastiest one I've got.
How many days are going to be on the test? Or quest?
One at most would be on the quest. Okay, so...
Can they go on a 2 afterwards too?
Okay, so if you write out those two answers, I need a place to go with all my answers. I'm running out of space here. Okay, hurry back, because I'm not done with the fun yet. So 24.3, how do you get the other one? Subtracted from 360 would be 335.7. Those are degrees. Now, are you done? Yeah, you got to go back now and do the minus version of the quadratic formula. Now, with me, I arrow up, highlight my first quadratic formula, and then just change it to a minus.
0.411.
Is it positive or negative? Negative. Okay, so this time we go, oh, I have a negative answer. So therefore I know I have to put it in the negative quadrant. Okay, now this is the one though, when you punch it in your calculator, when you do the inverse. If you do the negative sign, actually the cosine, it'll turn out okay, because cosine of a negative angle is the same as cosine of a positive angle. Your calculator should tell you a negative 65.7?
Yes.
Is that what I picked up? Okay. Which, we don't care about the negative. The negative coming from this inverse trig function thing, which I will teach you next time I teach you something, because I'll teach you why inverse trig functions do this. But, so that's 65.7, but you still have to go, oh, I'm in the two quadrants where cosine is negative, so I have 65.7 degree angles in those two locations. So 180 minus 65.7, which is 114.3, and then 180 plus will be 245.7. And you would think, okay, did all that work? I should have that should be my final answer, right? Because you squared both sides, you have to check the answers. And the question is, how and where do you check them? Right now, I'm going to tell you there's at least one answer there that is not a valid answer. Yes. You have to go back to the very beginning problem before you squared it. Have to be checking it before you square it. The beginning problem, where we had 2 sine of x equals 1 minus cosine of x. So what you're checking is, does 2 sine of 24.3 degrees equal 1 minus, was it 1 minus, shoot, I forgot my equation, it was up there, 1 minus 2 cosine, okay. Does that equal 1 minus 2 times the cosine of 24.3 degrees? You actually need to punch each of those in and see if they come out equal. You would literally have to punch it in your calculator. So you would get something like, this one will come out 0.823. This one will come out negative 0.823. What's that mean? These have to be equal. Those aren't equal? No. 24.3 is not a valid answer.
Oh, figuring out a eight.
Or, am I way over? Oh, you're right. Yep, I'm way over. Did I lock up rats? Okay, so we successfully got 24.3 thrown out of there. There's another answer that does not work. Front row, somebody in the front row, you got 335.7. Somebody in the second row, throw 114.3 in your calculator. And somebody in the third row, throw in 245.7. Find out which other one doesn't work. Okay, if you do 335.7, you got negative 0.823 and negative 0.823. So 335.7,
Oh my god.
you missed a lot. Okay,
We have to check it too?
245, because we squared both sides, we're checking it. Okay, and yeah, Shannon found it, 245.7.
It's the, they're the same, it's, but they're negative.
Yeah.
The sign.
Usually what makes them not work is the signs, because squaring it made everything positive, squaring it makes it change signs when it really shouldn't.
I thought you said we
So-
could plug this in our calculator.
You can't. We're plugging in 2 sine of, we checked 24.3 equals 1, we had to go back to the original problem and plug in the angle and see if the two sides are equal.
Yeah.
So 245.7 is also an invalid answer. Yeah.
When we check, do we need to check all or just one by each?
You,
Because
what makes them work or not work is the positives and the negatives. So just because one of these works, you no guarantee the other one does. You need to check them all. Sorry.
We always have 4 answers on these before we check them.
You might not have 4 answers. You might have like 0.911, 0.411 were both between -1 and +1 for cosine. If you did a quadratic formula and cosine had come out to be 2.5, cosine can't be that big, so you would have thrown it out from the get-go. So that could happen to you.
114 doesn't work either. It's the same instant.
But 114 should both be positive 1.823. Were they both positive? Not again. Okay.